Hello, today we have LRU Cache. Let me share screen. And design of data structure is a full constraint of least recently used LRU Cache. Okay. Okay. Discuss the recently used item first. The software requires keeping track on what's used and then, which is requires age beats for cache line. The track of the recently used cache based on them when a cache is used. Change of the cache lines change. Most used. Okay. LRU least used. Implement LRU class. LRU class in capacity. Initialize LRU cache position size capacity. Okay. Return the data of the value of key if key exists, otherwise -1. Update the value of the key if key exists. Update the value of the key if key exists, otherwise add key value paired to the cache if number of key value exists, says capacity. Evict the recent used key. Function get input must each or one. Okay, so here it is hash table for storage because we need to get input. Okay. Okay, input put 1 1 2 2. So we put 1 1 2 2. This is like cache data. Okay. Get 1. Evict cache. Get 1, get 3. Okay. So we have to have a first we have to initialize storage for that. And we have to initialize capacity. So max cap equal capacity. Self storage equal storage. When you get if key in storage in the storage so we return whatever we have in storage for this key. And here we have to also do move to the top of priority or otherwise we return -1. Now put its key if key exists. Otherwise it creates pair to the cache if number is capacity for operation. Evict the recent bucket. Okay, so what we can do, we can create a linked list for cache, and we can store data into linked list and into map, and then and then if we have we remove from the list the last one. Okay, so main idea is to create linked list right, right here. This. So we keep key and we keep value inside the linked list, right? And then we add value to if key exists. Okay, so update the value key in key exists, otherwise add key value pair to the cache. If numbers of k exceeds capacity from okay. So this is what we have to do on foot. Update the value of the key. Evict. So what if we also create this? If we create class called cache node, this class cache node will have um, in constructor we will accept key and value, and we do self key equal key self value equal value, and it's also it contains the next element, next and previous element. So it will be double linked list. And here, if we put we create node equal cache node. We put key value to it. So we have to add, and then we add if. But we don't have to add, right? We don't have to add if this is. If it's already in that. So it's if whatever we have, if self as contains if key in storage, then we get. So node equal storage, whatever we have for key. We add we add the new value, right? That's okay. We update val with the value, and then exist. Okay, add cache the value cache. Or else we just add create new node here, and we add self. So we create new node. And then we create, we have to keep max cap, increase it, right? Initial, okay, or decrease it. We have to keep a count of some kind. Okay, so we keep max cap and we keep count. Initialize it with 0, then we increase count here, and if our count more than max cap, what we're gonna do, we're gonna assign the, so we're gonna remove last element from the list, right? Like here. Effect. LRU Cache will execute too. So we add it second. For that, we have okay. We probably need to keep self tail, self and when we add element, right, we're not only adding it to hash, we're adding it to the list. Okay, so here we will home, we return and now. Okay, let's call it remove last. Remove last. What we're gonna do here, we're gonna store tail, then we're gonna remove the of storage. Okay, let's try to remove another remove. Call it a couple of times. So removing one node in a linked list when we have a linked list with head, it's right, and tail. So if you want to remove first we get node from probably node. If you want to remove node, we first, for example, B, right? First we're gonna get a node, which is B trap, and then C node, which is the next. And then we're gonna assign next equal C, and C pref equal A. Right? This is perfect. And we also have a, when we add in thing, right? Or when we get thing, we have to move to the top of the list. Let's call it top. So what we're gonna do, we're gonna do self-head like here. So for example, we want to move C to the top here. So here we have to add and we also have to add and. So whatever we are pointing to, we have to we are pointing head is pointing to A, therefore it should be pointing to our new. So self head next. I'll say. Then we gonna add new node after head, so self head next equals node. Then node 3 equals self head. Then node next equals A. Then A3 equals node. Okay, so we add into the top I think in both cases, right? No, this we add, but this we add top. So here we call top, and we add a node. So next, what we're gonna code is remove last. So we delete K from here, and then we call remove So key will be here. Node, pass node will be tail, right? Or whatever we have before tail. So we need to find out what will be key first. So key will be self tail path. And then we do key from here, and then we no, let's do this. Let's call it last node or tail. Then we delete tail key from storage, and then we remove tail. And then we decrease out. Okay. Yes, we have to move to the top, so we can call top node. You know what? We should add. We have to code add function, and because we're calling here self add, and top is also add. So code add. Add. In this add function, we will have to do all the same. But how we? Okay, so if we're adding, for example, we're adding this, right? Yeah. What we have to do, we have to get A as no, we have to add. The thing is that we have to add directly to to the node after header. So imagine we adding B right after the header, because otherwise, uh, because it's LRU cache, so B is whatever we add in is LRU, so we have to add it right after the head. All right. So we do B node, whatever we have self and next, right? Then on our side, so head next, whatever we have in node, then head next. Okay, we added node, node next will be E, and E have will be A. Wait, no, you probably node. So right here, imagine we add an A. So B will be whatever head is pointing to. Then whatever head next will be our node A. Then whatever our A next will be node B, and B previous will be A. Okay, and so when we do top, we don't need all this. All we need is if self head next not equal B, then we remove B from its current destination and we add B here. Okay. Okay, it's looking good. And I'm off time, but let's see, let's run it and see if it's working. Okay, 121. Yep, I do this. Okay, how to bell? Bell. Okay, this. Auto initialization thing. Okay, let's create new node like guardian node. Like this. Zero, zero. Right, doesn't matter. In this case, we don't have to check all the time. Node type has no attribute preview. And creating node, then so have next. Oh yeah, we have to assign this values here. So have next equal tail and say tail path next path equal head. Yes. Let's have not defined. Line 77. Yeah, so top is not defined. So top is not defined. Line 6. Yes, so LRU Cache which has no attribute each. So bad. Yes, so if we remove B, should put B here. Okay, key. It's tail. So remove tail. Problem with remove, right? Okay, how did I call it storage path? Okay. Oh, we don't have to remove. We have to get tail path. We are not removing tail. Let's go over because we are removing C, not tail itself. Yep, like in this example. I like how you see. Okay. Perfect. Almost on time, 40 minutes. Yeah, that's it. Thank you.